Hello, welcome back to the Atomix project. For this next little bit, I ended up with about 3 hours of video getting the display lines to work, being able to click on them so that we could then do the movement, then determining the win condition. I tried to edit out as much cruft as I could, and believe me, there was like half an hour has ended up on the cutting room floor, but it still left me with a really long video. So what I ended up doing was I ended up splitting it into separate parts, of which this is one. So the next 3 or 4 videos are actually the big long video, but once we get to the win condition, that's it. That's the end of this smaller subsequence of videos. So check out the playlist above, which should be above my head somewhere, for the other videos in this series. But without further ado, let's get started. Quick couple of announcements before we actually get to the code. First thing is, this book is still available, Python Pygame, Raspberry Pi game development, and A-Press asked me if I wanted to get involved in writing another book, and I said yes. And so here's the other one, which is Unity Networking Fundamentals, so creating multiplayer games within Unity. I wrote the first half of this book. I actually co-wrote it with Kajendra, and he wrote the rest of the book. But yeah, I'm super happy with it. I did a couple of examples at the start, so it's all about TCP connections in C#, how to sort of get a weather app, and then there's a tic-tac-toe game in there as well, and then later on in the book it shows you how to create a maze game. But yeah, it's all in here. It's not particularly thick, but it covers quite a lot of ground. But yeah, this is out now. Link will be in the show notes below. Thanks. Sorry about the AC noise. It's cold down here, and the heating's on, so that's why you can hear that in the background. What I ended up doing was I ended up creating a class called Trundle, and then inside Trundle, the Trundle is basically the sort of line that gets drawn, and it shows the directions. But I needed to add a collider to the line as well. So what I ended up doing was I ended up creating a game object. I found some code on Unity Answers that kind of got me halfway there. I thought it would get me 100% there. I ended up just redoing it because it was trying to be too generic and it didn't work. So sometimes finding code on the internet doesn't help you. So it did exactly what I thought it was going to do, which is basically create a game object, place it in the scene, put a collider on it, and then size it to those objects. So that's really what this code does. I'm not going to go back through it again, but essentially that's what it does. It takes the start and end points and then creates a box collider that fits on those directions, and then I add a component called clicked onto the same game object, and then when the line is clicked, it just sends an event back up, and that's all it does. And then this update here, this is part of the existing Trundle class. It just moves the material, so it animates it. So what you end up with is, if I run this, you'll see that we've got these 3 objects here. I'll just make this a little bit bigger. But if you watch, I'll clear this down here. If you watch when I click on this, you'll see that we have these directions are now shown to where you can actually go, and then to select a direction you click on this part of the trundle. So you click on that and you see that it says, I don't know if you can see that there, but it says -1 0 0. So in other words, it's going over to the right. If I click this one here, and I clear that one there, and then I press up, you'll see that it goes 1 up on the Z axis because Z is up on the screen. And then similarly, if I do this one here and then I click to the right, you'll see that it's moving 1 over in the positive direction to the right. So that's the sort of the problems that I ran into, and that's how I counted it. Was I basically created a game object, added a collider and a clickable thing, and then the click component is really simple. It's just that it's on mouse up as a button and then it clicks it. So this all works because I have a collider on it, so I can click on something that has a collider on it and then it acts as if I've clicked it as a mouse button. So that's what I've got there. for the movement part of it, I'm going to try this. So I already have this undo redo stack. So I'm going to copy this here. And then I'm going to go to the bit that makes that direction change. So if I go to, where's the directions allowed? It's one of these here. Where's Trundle used? Let's see where Trundle's used. For you, this is the next scene. For me, this has been a couple of days. So yeah, here we go. So if it's been clicked, then it goes to line click, and then it goes to clicked here, and then it goes to clicked here. Oh, and that only sends a vector 3. Is vector 3 enough? Well, it's sending this, which is direction lines. I think that should be enough. So if I go to here, and then I go to this here, and then down to this one, it prints E. So this is the print E part of it. Now this is part of the sender. So sender is going to have the game object. So instead of that, I'm just going to say var piece equals sender as this would be sender as direction lines. Oh, but I don't know what that is though. Direction lines is part of this here, so I don't know what object that belongs to. So I need to know the selected object. Okay. So I need to know the selected object. How do I know what the selected object is? Do I have that? Is that atom clicked? Okay. So now I can say selected atom equals sender as atom, I think it is. So let's do that. Private selected atom equals aim object selected atom. Oh, that's why. That should be atom. Okay, and then down here, instead of piece, we would have atom. So I don't need piece at all. Let's get rid of that. Let's get rid of that. And we'll sort that out in just a sec. But then if I do selected atom, and then the new position is going to be, well, that's going to be directions. Okay, so I need to get that there. So I need to do var directions equals sender as direction lines, and then I can say directions get. Oh, the direction's just that, isn't it? Okay, sometimes it is easier to do. Selected atom equals null. Okay. So that is going to be, let me move this out. Goes new command, and then that's going to be game object, and then it's going to be whatever the position is just now, and then whatever the new position is. So I'm just going to move it one across from there, plus E dot vector, E equals position. Oh, right. I just want to move it across just now, just to make sure it's working in the right direction. And then I want to turn off those direction lines. So I want to say direction dot clear, like that. We don't have a bounce, so we don't need that. and then we're adding that to there. So this action here should move the piece. So move piece slides the piece out of the road, and that's all we need it to do. Which is from the original Lost Orbit game. Not Lost Orbit, that's the game I worked on when I was at Pixelnuts. Lunar Lander game. Lunar Lockout. I'll get it right eventually. Okay, so click on this one here, and if I move over here, it should move it to the next square. And it does not. Move piece command. What is it not like? Oh, it doesn't like slide piece. Oh, okay, so I need slide piece on there. Aha! Okay, well that's easy done. So what I can do is I can go to our pieces. So where do we have our pieces? We have our prefabs, and we have an atom. And then I'm just going to add, these are all box colliders, transforms, and then we do slider, slide piece. There we go. So now, click on that, and then when you click on the left, it should move it one across. Boom! There we go. Okay, that's good. So again, we should do that there, and we move that down to here. That moves that there. Also, it's not registering that it's got a direction that way. That's interesting. Need to figure that one out. So that's moving that one down there, moving that one down there. It's not recalculating the direction. Oh no, it was recalculating the directions there. So it is sort of working. So there's something wrong with the directions. Well, that raycast isn't quite working, but we can see that we can move this around the board. So now we need to figure out is the position there. So we're going to do that next. So go back into this code here. I can say var directions allowed equals get component directions allowed, which is that, and then I can say the new position is directions allowed equals get, and then I don't know the direction. So what does E do? E directions returns a vector 3, which I'm going to guess contains all the directions, which has got forward, back, left, and right. The direction actually, I'm going to write a note for this. This contains the north, south, east, west directions mapped to new positions that the current piece can move to. E.g forward can move 5 spaces forward. If that makes any sense. So when we pass in a cardinal direction of up, down, left, right, which is completely reversed for what you are, then that will return 5 or 7 or whatever it is. Okay, so that makes more sense. So let me see, new position is that. So my guess is that this new position is going to be not good. It's going to put us in some kind of weird state. So if I move this one here, it's going to put us in here, I reckon. Yeah. So we need to subtract 1 from that, because obviously now we're stuck in the wall. So, and this is going to move it up to here as well. Yeah. And then this one's going to put it in the wall, and so on. Okay, so we need to do that. All right. So the easiest way to do it is to cheat. So we do that there. We do return directions minus direction. So that is going to subtract 1 from whatever value we get. So if we go 5 along that way, it's going to be 5 minus 1, so it's going to be 4. And similarly, if we do minus 4 minus 3, then minus 1, it's going to bring us back there. Okay. So we do that, bring it to there, this one bring it to here, this one bring it to here, and now everything's working properly. So now we can see the game's actually coming together quite nicely. Oh, that one's not quite working. We'll figure that one out. Yeah, we're still getting kind of weird things there, but okay. I think it might be because it's the last. Things aren't getting cleared. I think that's what the problem is. So let's do that. So we're gonna go to this one here. So we're gonna do directions allowed, new direction equals direction allowed. So we do that, and then we say directions allowed dot clear. It's not a clear. So play pieces that. No, so I see the direction. Blah 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 blah. Turn on. Oh, okay. So just okay. So and then turn off. So when does that get called? That gets called. Okay, so that gets called then, and then it gets called then, and then it gets called then. So we're not using object selection in here. I don't think we are, Yeah, we're not using object selection. So object selection obsolete. Let's mark that as being obsolete because that means we can have it inside. Well, we should be able to have it in our warnings. Messages. Here we go. Make obsolete. No. Wonder if we can. Yeah. As long as it's marked as obsolete, it's fine. We can tidy that up. And then inside here, where do we want to do it? So I think if I select this one first, I think we get the true directions. So we select this one here, do that, and then we do that. No, it's still not doing over to the right there. Yeah, and then it gets trapped, stuck in there. I think this one works out okay. No, see, that's got an issue going that direction as well. There's got to be something down here that's blocking that, because everything else works just fine. It's not going far enough. That's why. Ahahaha. So if I go to directions allowed, okay. So if I go to directions allowed, it only goes 5. Now, we need to make it go further than that. It's got to go much further than that. So let's make it 20. So that should fix the issue of it's not finding the wall. So if I go down here, that's it, it's fine. So this should now find this wall over here. Boom. So now you can see that this is now, we need to block this out for this player as well. So we've got to make that as player piece or atom. So we need to do or actually let's do layer mask or equals 1 layer mask dot name to layer atom. So we'll put that as a layer up here, so we can say private static string atom piece equals atom. So atom piece is that. Say atom piece is that. So it should. So if I bring this down here, and then bring this to here, and then down to here, see, it doesn't like that. I think the issue is that it's hitting itself. I think that's the problem. Okay, I'm going to leave that out just now. obviously we need to fix this. We need to fix collisions. We gotta ignore ourselves though. So got that one there, that one goes to there, that one goes to there. See, that's allowing me to go that way because it's not blocking. But everything else is working. All these are moving around. Okay. Yeah, that's not blocking that way because that would be nice. You could block that way and then. Yeah. Okay. What I'm gonna do though is I'm gonna remove every one of these has got a capsule collider on it, and I'm gonna turn them all off. Each one of these is gonna get their capsule collider turned off because I think it's actually interfering with the collision detection. And then you got white no use there, which is a box collider, and then we get background color, which has also got a box collider. But this one isn't axis aligned; it actually sticks out over the edges. So I'm going to turn off that one as well, and I'm hoping that's going to fix my issue. So what I ended up doing was I started the raycast a little bit out from the existing raycast. Sorry, the existing object, so it's like 1/2 out, and everything's on unit squares, so it's basically starting, it's at 0, so it's starting at the very edge of the box. And then I cast it out in the direction, and then I have my layer mask, and I've got it set to 20 distance, max distance, which you probably get rid of. And then if it hits it, then I just add the direction as normal, and then when I do this, everything's working, everything looks okay. So if I move this down here, move this down here, move this down here, when I select this one, you notice that it's showing in the directions, and it's right up against this one here. But if I click this one, it was going to halfway here, and I think the reason is because it was picking up this over here. I'm hoping this works. I'm stalling because okay, that did work. Right, so removing those colliders actually helps. So now you can see that we've actually got a bond now, where we didn't have a bond before. So if I block this one out here, we can now start to see that the puzzle game is actually starting to take shape. Continued in the next video. Don't you hate it when people do that? Keep an eye out for the next part of this video, and it's going to be out next Thursday. I hope you've been enjoying this series so far. Thumbs up if you did, thumbs down if you didn't, and let me know in the comments where I can improve. If you've got this far and you like what you see, please consider subscribing. Hit the subscribe button and notification bell, and you'll get timely reminders of when I post a video up next. But thank you all for watching, and I will see you in the next video. Bye bye.